So a little
Yes,
professional
very,
courtesy back
very
and forth.
important.
So, Dr. Easterbrook, welcome to the committee, and I will turn it over to you. And just a little ground rules. During our work sessions, we try to keep it a bit more informal so people can ask questions because we consider this a learning opportunity for the committee here to be able to understand what's going on and what you're presenting. So there will be a bit more informal. We'll stop for questions as people have them going through.
That's fine.
Okay.
I'm open to any and all questions at any time. Let me start by saying that I'm happy to be here and share the information that I have with the committee. I have a lot of data, probably more than you want to know, and a lot of it is in graphic form. And what I will do is I'll show you the factual data for some of the assertions that are in Senate Bill 5502. And to do that, I'm relying on some sayings of our astronauts, which you see on the screen. In God we trust, all others send data. So I'm bringing data, and I don't ask you to believe any opinions that I may have. You'll hear very few opinions from me. What you'll see is a lot of data, and I hope that the data is clear enough so you can make up your own minds, and you won't need to ask what my opinion is. Whoops, let's go back one. To begin with, I need to say who I am, primarily because there has been a lot of politics injected into science these days. And so I am simply a geologist with 50 years of expertise and research in global climate change all over the world. I'm a lifelong environmentalist. I am a scientist. I'm not political. I don't have any particular bias towards either party, so I have no political agenda. I'm not associated with or funded by any business group. I'm not a shill for big oil, big coal, big anybody. All of my research has been funded by governmental agencies. And I'm currently working actively with an international group of geologists, atmospheric physicists, meteorologists, astrophysicists, oceanographers, and sea level experts, and other sciences in various parts of the world. Now, that's where I'm coming from. I thought I might start by listing some things that you probably don't know about or haven't heard about because the news media isn't telling you. And I've listed a few of them here. There are a lot more, but some things that I will touch on later in the presentation. And that is that global warming ended in 1998. That may come as a surprise, but I'll show you the data for it. And it is indeed true. That has been admitted by the chairman of the UN group that has been pushing CO2 as causing climate change. Even he admits there's been no global warming in 15 years. The Antarctic ice sheet is not melting. Contrary to headlines you'll see about every other day that the Antarctic ice sheet is melting at an accelerating rate. It not only is not melting at an accelerating rate, it's not melting at all. The main ice sheet, and I'll show you the data for this, is in fact growing, not melting. So we don't need to fear that the ice caps are going to suddenly melt and cause all kinds of problems for us, because they aren't. Sea level has been rising globally and also locally at a rate of about 7 inches per century, as we're thawing out from a little ice age which occurred about 500 years ago. And the projections of anywhere from 5 feet to 20-foot rise of sea level, as you'll see when I present the data, is beyond reality. Snowfall is not below normal. There have been headlines from time to time about, in the Cascades, certainly, that the snowfall in the Cascades is diminishing because of global warming. That's not true. For the past 5 years have set snowfall records, both globally and in the Cascades. CO2 cannot possibly cause global warming. That will come as a shock to you, I'm sure. And the reason is that there's so little of it. It is a trace gas. It has increased in its atmospheric content by only 8/1000ths of 1%. If you double nothing, you still get nothing, and I'll comment more about this later. Severe storms are not more frequent than normal. When we get a big snowstorm in the east, they say, oh, it's because of global warming. When we hear about a hurricane on the East Coast, they say it's because of global warming. It isn't. And I will show you data that shows that actually the extreme events, severe storms, are actually declining. They're not becoming more frequent. And finally, you may be surprised to know that the oceans are not acid. Oops.
Mr. Chair? 1 second.
You want to go back?
I think Senator Ranker has a question.
Oh,
I'll have several later. Most of them I'll wait until the end. Just on that last point, the oceans are not acid. Are you saying that ocean acidification does not exist, or are you saying the oceans entirely are not acid? I think all of us would agree with that. Nothing is an acid, so.
the oceans are not pH, which is a measure of acidity, is measured on a scale, and 7 is neutral. The oceans have a pH of 8.2, which is alkaline, not acid. And I'll show you why they are not going to become less alkaline, much less more acid, with increasing temperature change, if that in fact were to happen.
Thank you, Mr. Chair. So just to clarify my question, I'll be a little clearer here then. Do you believe that ocean acidification exists in the world's oceans today and here in the Northwest?
No, I'll show you the data. I'll talk about this in detail. If you'd like to wait till I get to those slides, it'll be clearer, I think.
Badly. Thank you.
It's very clear, and I'll show you the data. So what I did was I looked at specific issues that form the basis for Senate Bill 5802, and I listed 6 of them. And so what I did was I pulled out data that relate to all 6 of these premises that are inherent and form the basis for Senate Bill 5802. Regardless of the language of the bill, this is what the bill was based on as of this weekend. And you can read them, but emissions of greenhouse gases is the principal cause of climate change. A lot of data, I'll show you that. Sea level is rising at an increasing rate because of global warming. That's not true. I'll show you the data. Frequency of severe storms is increasing because of global warming. That's not true. Reduced winter storm packs and decreased summer stream flow is not true. Increasing acidification of the state's marine waters. That may or may not be true in terms of the state's marine waters. Certainly it's not true of the oceans globally. And finally, the production of more electricity from renewable energy while phasing out coal-powered electricity generation. I'll just show you some data that shows what this would cost, and without commenting on whether coal plants are good or not. I'm not particularly in favor of coal-powered generation, but there are some numbers you might be interested in. So let's take these one by one. The first one is that greenhouse gases from human activities.
Dr. Easterbrook, Senator Ranker has another question.
Can you go back to the last slide? I didn't understand what your point number 6 was trying to get at. I heard you mention coal, that you're not necessarily in favor of coal-fired generation. What's your point there? What are you going to tell us about?
My point is to show you the relationship between coal-powered generation and other forms of electricity generation, how much of it is from each of these categories, and what the cost of each is, and what changing from one to another might involve. I have no opinion on that. I'm just going to show you some numbers.
And how that relates, sorry, Mr. Chair, and how that relates to climate. Or you're just going to show us the costs on the generation?
Well, it relates to climate because the rationale for moving from one form of energy generation to another is climate. Is how much CO2 you put in the atmosphere. If that's not a realistic assertion, then it doesn't matter. But if it is, then there is a concern that's related to climate.
Thank you, Mr. Chair.
So let's look at greenhouse gases. But before I do that, let me say something about global warming. There's nothing new about global warming. It goes on all the time. It has been going on for thousands of years at much higher rates, much more intense for longer periods of time than we've experienced in the last period of global warming since CO2 began to be elevated. This graph shows temperature on the left-hand side and the date, year on the bottom. And what you will see is that there was a period of cooling from 1880 to 1915. Temperatures were going down. This is a global record. And then from 1915 to 1945, the climate warmed. And then it cooled again from 1945 to 1977. And that warmed again from 1977 to 1999. And since 1999, it has cooled slightly. Not a lot, but slightly. So what does that mean? Well, if we go back to the warming that occurred from 1915 to 1945, shown by this curve here, global warming occurred without any increased CO2 in the atmosphere. This was before the big surge of CO2 emissions after World War II in 1945. So if you want to put a mental line in 1945, that's the breaking point between increasing CO2 and insignificant changes in CO2 prior to that. So this warming took place prior to increased emissions that occurred after 1945 and cannot possibly be ascribed to CO2 as a cause. Cannot be. And then in 1945, global emissions began to escalate very rapidly. And for 30 years, as the escalation continued, and we put more and more CO2 in the atmosphere every year, we had 30 years of global cooling. So the question then is, if we've had escalating CO2, which is supposed to cause global warming, why did we have global cooling during the initial period when CO2 was escalating so rapidly? It doesn't make sense. And then finally, there was a period from 1978 to 1998 when global temperatures rose again, and CO2 was still rising. CO2 has been rising throughout this whole interval. So there's only one period when CO2 was rising at the same time the temperature was. And we can take that back even farther. If we go back 500 years, this graph shows essentially temperature on the left-hand side and the year AD on the bottom. Each one of these red peaks is a warm period. Each one of the blue peaks is a cool period. Climate is not constant. It's changing all the time, and it changes in cycles, warm, cool, warm, cool, warm, cool, with about a 30-year time span between each one. So we could count these warm periods, and we can count 20 periods of global warming and global cooling that have occurred in the past 500 years, none of which could possibly have been caused by CO2 because CO2 had not begun to rise until 1945. In other words, we have an instance here of 20 periods of global warming, similar to what we've experienced in the period from 1978 to 1998, that could not have been caused by CO2. They were caused by natural causes. That's important. 20 periods of global warming that can only be ascribed to natural causes in the last 500 years. If we go back even farther, if we go back 10,000 years, this is temperature on the left-hand side. Sorry, it's not labeled. And these are years before present on the bottom. The red curve you see here these are temperatures that are higher than the present temperatures. And so this is 10,000 years ago at the left-hand side. This is present on the right-hand side. Look how much of the last 10,000 years the temperatures have been higher than they are now. Almost all of the last 10,000 years, except for the period beginning about 1,300 years ago, almost all of that, the temperatures on Earth were actually warmer than they are right now. Warming is nothing new. As a matter of fact, it's the norm for the last 10,000 years. The blue periods here are from the Little Ice Age, which was a period of global cooling that occurred from about 900 AD and may still be going on for all we know. So what about all the claims then that temperatures are warmer now than they have ever been? These are patently not true. And those claims come from manipulation of data. Here is the real original data. The hottest year of record, number one for the number of, this is the number of temperature records that were broken. Number one is 1936. Everybody has acknowledged that 1936 was the warmest period, warmest year of this century, until NOAA and NASA began to manipulate the old data and made it cooler. And then they elevated the recent temperature, made them warmer, and so they come up with a headline saying, oh, it's warmer now than it was then. This is the original data before they manipulated it. You'll see that if we take the top 10, number 2 was 1934, 3 was 1939, 4 was 1931, 5 was 1930, 6 was 1933, 7 was 1938, and guess what? They're all in the 1930s. 1930s was the hottest decade of the century, not the present, not the last decade, but the hottest of the century also. Over here, you look at all these 2000. These are all second tier, 10, 11 through 20. This is what the present temperature has been doing, and it's nowhere close to the other. And if you plot that data, this is what it looks like. This is a number of temperature records that were broken in any given year. These are years down here. So here we are right here, and now we're breaking somewhere around 2,000 records, temperature records for warmth. And you think, wow, 2,000, that's a lot. But look at what it was doing in 1936 and 1934, 10,000. We are setting record highs at a rate of about only a fourth of those that occurred in the 1930s. This is hard data. You can, question?
No, go ahead and finish the slide, then we'll have a question.
Pardon me?
Go ahead and finish the slide, then we'll have a question.
Oh, I'm essentially finished. The point here is that the 1930s were the warmest decade, and there were 10,000 temperature records set in 2 years, in 1936 and 1934, and we're setting now records somewhere in the world at a rate of about a fourth of that, about 2,000.
Great. Senator Ranker has a question.
So let me rattle off a couple of peer-reviewed scientific facts that I have before me, and I would like your opinion on those. I understand that last November was the globe's 333rd month of above average global temperatures. To put that in perspective, that would mean that if you are 27 years old today, you have never experienced a month with a global temperature below the average.
You have a question, Senator Ranker?
Yeah, I asked it in the beginning.
Thanks.
I want to know his opinion on this. And then the second one is that, again, peer-reviewed data here.
Senator Ranker, we'll come back to that one later. We're going to let Dr. Easterbrook. No, we're going to let Dr. Easterbrook finish his presentation.
I'm happy to answer your question, but I'll show you some data. Let me answer it for you.
Because what you just put out in your slide goes contrary to the data that I have before me. So I'm just curious if what you're basing your metadata on, where your samples are taken from, and then also what's your opinion of the data that I have before me, which seems contrary to what you're putting forward.
I don't doubt that it's contrary. And what I just said a moment ago was that I'm showing you the original data, and what you're looking at is the data that has been tampered with by NOAA and by NASA. And I could show you curves of what that data looked like in 1936, what it looked like in 1980, what it looked like in 1990 and 2000. And the temperatures, the high temperatures in the 1930s get cooler every year. They put out a new issue. And the temperatures that are in the 2000 plus get warmer because they have frankly tampered with the data. That's the difference between what you're looking at and what I'm looking at. Mine is the original data.
One quick follow-up, Mr. Chair.
Sure.
So National Science Foundation, NASA, and NOAA have manipulated the data.
Yes, that's true. I can show you the data that they have manipulated. I'm not saying that they have done something which is scurrilous and evil. What I'm saying simply is something that everybody will agree on, and that is that they have what they call adjusted the data. And if you look at how they have adjusted it, the 1930s always get lower because of the adjustments they made from the original data, and the 2000 plus always get warmer. That's the case, and I can show you data that will indicate that if you like.
Thank you.
Great.
Here is a curve of what's called a heat wave index. These are for really hot times, and again, simply to point out what I was mentioning a moment ago, the heat wave index for 1936 is right here. And look at the period of 1930, 1940 relative to where we are now. This again confirms what I have just said, that the 1930s were warmer than they are right now. We had more heat records broken. We had higher temperatures. It was a hotter decade. And there's hard data for all of that. We hear about droughts. We had a drought last year in the summer in the Midwest, which was not a good thing, devastating. These things happen. This is what's called a drought index, and the down trending curves here, which are colored yellow, are times of drought when the rainfall is below normal, and green is wet. And so if you just look at from about roughly 1980 something up to about 2000, you'll see that actually there are more wet times than there are dry times. This is not an ongoing drought. And if you look also at the duration of the drought, you'll find they generally last 2 to 3 years, something like that. And then they move on. So the drought last summer, was bad. There's no doubt about it. It cost a lot of farmers a lot of money, but it wasn't in any way unusual. Again, more data that looks at the relationship between temperatures. This is the count of hot temperature records set, similar to the data I just showed you. 1930s were by far greater than recently in the past couple of decades. And look at the relationship to CO2. There was no correlation whatsoever to CO2. And in fact, this big hot spell in the 1930s occurred before CO2 began to rise. And so it cannot have been caused by CO2. And then we've had some cooling in between and then another warm period. There's nothing mysterious about global warming. It happens all the time. That's not the issue. The issue is what's causing that global warming. And the same thing is true if you take almost any place. Here are 100-degree days compared to CO2 for New York City. Again, there's no relationship between CO2 and the number of hot days in New York. So the conclusions are that 80% of all maximum temperature records were set prior to 1960, before accelerated human CO2 emissions began in 1945. Thus, the present conditions, the present warming, or the recent warming, has nothing to do with CO2. Present drought conditions in the Midwest are part of a normal weather pattern. This is weather, not climate. Climate is generally taken to be a period of about 15 years or so. Weather is day to day, year to year, whatever. So if you're looking at an annual number, that's weather. It's not climate. And so what we're looking at when you see a severe storm or a period or an unusually cold or warm winter or summer, what you're looking at is really is weather and is not related to global climate. Weather extremes happen all the time, regardless of what the climate is doing. And the present drought conditions are not as severe as those in the 1930s, the warmest decade of the century before CO2 level. So what happened to global warming? I mentioned earlier that global warming stopped in 1998. And my guess is you probably have never heard that, because the press will not print anything which is adversely related in any way to CO2 as a cause of a climate change. But here's the real data. The graph on the left-hand side is temperature on the left-hand axis and year. This is satellite data. This is the best data we have. It is untampered, unadjusted. It is taken from real readings from satellites, and it gives a good overall global average. This peak right here is 1998, and since then it has gone down, came up a little bit, and in recent years has been on a sharp downward bend. I'll show you what the overall trend is for the decade in a moment. And that is confirmed by ground measurements. These are mostly ground measurements. The top two here are satellite measurements compared to ground measurements, which are these lower three colors right here. And you can see the shape of the curve is essentially the same. So the ground data and the satellite data essentially agree that we have indeed had global cooling for the last decade or two. Here's the trend. Trend means the rate at which it's getting warmer or cooler. So beginning about 1998, which is right here, this is the trend. Down is colder, up is warmer. Look at the downward trend between 1998, and this only goes to 2004, but it's continuing on down. These are winter temperatures for the U.S. And again, look at the same trend. Starting about 2001, the average winter temperature is going down at about -4 degrees during this period. That's the trend. It's getting colder at a rate of about 4 degrees. Another plot of that same sort of thing, again showing the green line here, cool is down, warm is up. So again, showing a cooling trend since about 2001. And all the while this is going on, we hear in the headlines that global warming is accelerating and it's getting hotter and hotter, and in fact it's getting cooler and cooler. Here are winter temperatures for the past decade, from 2001 to 2010-11. In the north central states, it's 8 degrees cooler per decade. The same in the north central area. And they range all the way from about 2 in the Pacific Northwest, -2 to -3 in the southeast. All of them, however, are colder. It's not getting warmer in the winter, it's getting colder in the winter. This is NOAA data. I'm sorry, this is NCDC, that's NASA data. Beg your pardon.
Hey, Dr. Easterbrook, Senator Ranker has a question.
Thank you, Mr. Chair. Two questions, if I may. The first one is, have you taken into account volcanism, solar radiance, and other factors such as that in your data? Have you removed those from the picture? Or included
Sorry, I
those?
didn't understand.
Like volcanic events, solar radiance, and other issues like that, have you taken those into consideration when accumulating your data?
Yes, but this data doesn't, this speaks only to the temperature change. It doesn't speak to the cause. And we can talk about the cause later, but the answer to your question is yes, I've considered those in great detail. I work with some solar physicists, some atmospheric physicists, some astronomers, and we all agree on what's happening with the solar. In terms of volcanic activity, I'm a geologist, and I can judge that for myself. And I can tell you that volcanic events are very short. They're like little punctuation marks here and there. They don't persist. They're not a factor. They give you a 1 year, 2 year spike, and then they're gone.
Okay, so in the follow-up, and this gets back to the data I have before me, which seems, again, contrary, but so you're talking about a trend, particularly over the last decade, maybe 15 years of cooling, yet what I have before me is that 2000 to 2012 was the warmest 12-year period in instrumental record. In other words, since we've been recording heat of the planet and what we're in, the last 12 years were the hottest on record. And that's peer-reviewed data that I have before me. And so my question to you is that because what I'm looking at has been manipulated by NASA and NOAA and the National Science Foundation, or what's the difference here? Because we obviously have conflicting information before us.
Right. I don't know what your data is or where it came from, so I can't answer that specifically why it's different. What I can tell you is that the data that I'm showing you is original data, and as I've just shown you, the 1930s were a warmer decade than the past decade, if you use original data. That's what I'm telling you.
Thank you.
And if you have something that's different than that, my guess would be, although without knowing what your data is, I can't say for sure, is probably that this is manipulated data by NOAA, NASA, or the subunit of NASA that deals with climate. And what they do is they make what they call adjustments to their data, the net effect of which is to make the earlier warm periods, like the 1930s, cooler, and raise the temperature of the last decade artificially, not from the original data. Mine is original data.
Is this a conspiracy?
I'm not into conspiracy, so I have no comment on that. I'm simply a data purveyor, so I'm going to present you with data, and you can draw your own conclusions. You probably didn't realize, if you watch TV news every year, that Europe is having the coldest winter in 100 years. I hadn't heard that, and I started looking up the data, and I'm aware that Moscow is buried under 6 feet of snow. They're having the coldest winter in 100 years. Moscow is virtually paralyzed. They had a traffic jam that was 100 miles long. That's true of all of the Central European area, Germany, Poland, Russia, Norway, Sweden, and also Great Britain. This area is having the bitterest, snowiest, coldest winter in 100 years. So much for global warming. This is England, and England is having the coldest, snowiest winter in about 50 years. They're not quite as cold as this part of the country. You'll never see this on TV, although it's big news. And now the news media in parts of Germany, Poland, and parts of Russia are finally beginning to say, oh, yeah, that's right, it is the coldest winter. How can we have that kind of thing going on if we're supposed to have accelerating warming? Cold costs lives. Cold is more dangerous than heat. You kill more people in a cold winter than you do in a hot summer. And in England this year, the coldest spring in 50 years this is just in the spring, has cost 5,000 lives. 5,000 people died for causes that are attributable to cold. And there are another 2,000 extra deaths in just the first 2 weeks of March, 3,000 something in February. And the only point I want to make here is that cold is a greater enemy than heat, than warm. Warmth is good, cold is going to kill more people. So the conclusion is that global warming ended in 1998, and by that I mean modern, which is the warm period that everybody agrees on occurred between 1978 and 1998. There's been no global warming in 15 years. The temperatures have not exceeded those in 1998. And the global warming that took place between 1978 and 1998 has been replaced by global cooling for the past decade, despite the fact that CO2 continues to rise. U.S. winters are cooling at a rate of -2 to -8 degrees during the past decade, again, inconsistent with global warming. That's because global warming ended in 1998, not to say there isn't global warming. Temperatures today are not at all-time highs. Most temperature records, as we were just pointing out, were set back in the 1930s, and most of the last 10,000 years has been warmer than it is right now. The Antarctic ice sheet is growing, it's not melting, and I'll come back to this in a minute and show you the data for that. We hear every day, or I hear every day, accounts that, oh, the polar ice caps are melting at an accelerating rate, and so we're all going to drown from rising sea level, and I'll show you the data for that. And as I said, most all the 10,000 years has been warmer than present. So let's address the question, are the polar ice caps melting? And here are a couple of quotes I'll just let you read for yourself. This is a magazine cover, polar ice caps are melting faster than ever. Well, guess what? There's no polar ice cap at the North Pole. There's an ocean. There is no ice cap at the North Pole. So we don't have to worry about it. The ice there is only about 3 meters thick, which is inconsequential in terms of the total ice of the continent. This is what it looks like. It's floating sea ice. There are no glaciers at the North Pole. The Arctic sea ice fluctuates, the aerial extent. There have been times when it was warmer and you could sail ships across the Arctic Ocean. The Chinese did it in 1420s. And we hear a lot about the polar bears who are in trouble because the sea ice is melting. But what I can tell you is that the polar bear population has gone from 5,000 to 25,000 during that same period when the sea ice was supposed to be melting. And they survived 10,000 years of climate warmer than today, so they're going to be just fine. Let's look at the Antarctic ice sheet. And this is what you'll see in the headlines. It's melting at an accelerating rate. This is untrue. It's actually growing, not melting. Antarctica consists of a continent with a huge ice sheet. This is the Antarctic ice sheet. It's about 15,000 feet thick at its thickest point. Temperatures there are exceedingly cold. I'll show you those in a moment. There's a little arm right here called the West Antarctic Peninsula that has warm water around it, which has been melting some of the floating ice there in recent years and causing some glacial melt. But this is a minuscule part of the total volume of ice that occurs on the continent of Antarctica. And the reason is that the average daily temperature in Antarctica is 58 degrees below zero Fahrenheit. The last winter temperature at South Pole reached minus 106 degrees. To get any ice to melt, you would have to raise the average daily temperature from minus 58 to 32 degrees, which is the melting point of ice, plus another 10 degrees or so to get any appreciable melting to occur. You would have to warm Antarctica 100 degrees to melt the Antarctic ice cap. How likely do you think that is? I'll let you judge for yourself. It's not going to happen. The other thing about Antarctica is that because of the situation at the pole and the continental area, it makes its own weather, and there is a strong weather gyre that goes all the way around Antarctica, and the Antarctic ice cap has not disappeared in 15 million years, despite temperatures considerably warmer than we have today. Antarctic ice cap is not melting. We have ice cores through the ice cap that show us that there are no gaps in the ice record. If the Antarctic ice cap had melted before when temperatures were warmer, we would have gaps. We don't have them, which means that the Antarctic ice cap is exceptionally stable. It's much more stable than temperate glaciers. It's not going anywhere. Here is the record at the South Pole, which has been kept since 1957. This is the average, and you don't see any change in the temperature at the South Pole. And there are two stations that record temperatures. One is the South Pole, and the other is Vostok, which is a Russian station, and they show the same thing, namely that there has been no warming in Antarctica since records have been kept in 1957. again, emphasize the point, the Antarctic ice cap is not melting. I'm going to skip this in the interest of time and move directly to CO2 as a possible cause of significant global warming by itself.
Dr. Easterbrook, Senator Billick has a question.
Thank you, Mr. Chair. So when we're talking about the melting, how about glaciers? Because I've seen the empirical evidence of glaciers melting. So do you disagree with that evidence, or do you think that it's something other than warming that's causing that?
No, warming, certainly, I agree with that totally. And what I have said from the beginning is that we've had a number of periods of warming, cooling, and the answer to the question is during periods of warming, of course they melt. During times of cooling, they advance, they grow. So glaciers grow, recede, grow, recede, grow, recede. And we can look at the record in Greenland, for example, and we'll see that the record there, the temperature record there, is exactly the same as the global temperature record. And so the ice in Antarctica, the ice in Greenland was surely melting at a different rate from 1978 to 1998 than it was during the cool period between 1945 and 1977. So what I'm saying is, yes, global warming causes glaciers to melt. That doesn't prove what's causing it. I mean, hell, I had hair before global warming. I don't make a cause and effect connection there, and you can't make a cause and effect connection just because CO2 happened at the same time to go up at the same time that the climate warmed. Because in all these earlier periods, there was no CO2 factor, and it still got warmer.
Thank you. But you said the last 12 years we haven't been warming. So are you saying that that means that glaciers have not melted in the last 12 years?
No, not at all. What I'm saying is that we have a very good record of the glaciers' advance and retreat during the past century. And from 1880 to 1915, glaciers advanced to almost their maximum position, certainly in the last several hundred years. They advanced. From 1915 to 1945, they retreated like crazy at a rate probably greater than the last decade. And then in 1945, the climate got cooler, and they advanced again. And they advanced to positions that were actually down valley in many cases from their earlier ones. And then it got warm again from 1978 to 1998, and it began to retreat again. And then since 1998, many of the glaciers have stopped retreating, and some are starting to advance. This is true in Alaska, it's true in Scandinavia, true in some parts of South America, but not every glacier behaves the same way, so not every glacier has stopped melting.
Thank you.
It is the nature of glaciers to melt when the climate warms. Oops, let's go back here. Here's a critical question. Is CO2 capable of causing global warming? That's what underlies all of these discussions. And that's the main contention of the whole climate change debate. What you may not be aware of is that there's almost no CO2 in the atmosphere. It's very small. It's 39 1,000ths of 1%. If we take a bucket of air out of this room and measure it, we will get 39 1,000ths of 1% CO2. It's almost nothing. If you double nothing, you've still got nothing. Since 1950s, since this big escalation of emission of CO2, the composition of the atmosphere, the CO2 composition, has increased by only 8 1,000ths of 1%. That's almost as close to nothing as you can get. You can triple that and you still have nothing. There is not enough CO2 in the atmosphere to do much of anything. And then you add to that CO2 accounts for only 3.6% of the greenhouse effect. Only 3% of the greenhouse gas effect is CO2. 95% is water vapor. So the point of this is that CO2 by itself is incapable of significant global warming. That's the bottom line. I'll say it again. CO2 by itself is incapable of causing significant global warming. And so how do we get these projections in? And we get it because the climate modelers who depend on computer models rather than real data for their conclusions have decided that if CO2 goes up, water vapor will also increase. And as water vapor increases, we kick in this 95% of the greenhouse effect. So virtually all of the temperature increase during the warm period we had in 77 to 98, virtually all of that they would account for by water vapor in their models, not CO2, water vapor. So the question is water vapor increasing? Well, here's water vapor. Here's water vapor going back to 1947. Water vapor, if water vapor is increasing as CO2 goes up, and that's what's levering the global warming, then you might have an argument for their models. But water vapor has actually decreased since 1947. Look at the downward trend. Down is less water vapor in the atmosphere. And these are various levels of the atmosphere. So in order for their models to be correct, they must show that there has been an increase in water vapor in the atmosphere, and it's just the opposite. There is less water vapor in the atmosphere now as CO2 has gone up, not more, and so their models are totally invalid. Their models will not work without an increase in water vapor. There's another effect of CO2, which is called a saturation effect. If you take a dry sponge and dip it in a bucket of water, it'll soak up water. If you take a wet sponge and put it in a bucket of water, it doesn't soak up very much more water, does it? Because it's already saturated. And CO2 operates the same way. There's a saturation level wherein the CO2, which is in the atmosphere right now, is mostly saturated with respect to capturing of the frequencies of heat. And so on this curve right here, this is the degree in possible temperature change with increasing in atmospheric carbon dioxide. This 1950 level is right here, 2008 level is right here. The maximum amount of temperature change you could get from the increase in CO2 from 1950, when the whole thing started to escalate for emissions, and now is less than 1/10 of a degree. This is basic physics. What about just making a correlation between CO2 and temperature? On this curve, this is atmospheric temperature, atmospheric CO2 on this side and surface temperature on this side. So here's the CO2 curve, which has been increasing, been going up steadily, no doubt about it. From 1915 to 1945, we had global warming with no increase appreciably in CO2. So CO2 didn't cause that warming. In this century, hotter than it is now. And then when CO2 was escalating in 1945 on, we actually had global cooling. The curve is actually going the opposite direction as the CO2 curve. If CO2 causes global warming, why do we have 30 years of global cooling when it began to escalate? Doesn't make any sense. It's only in this last period from 1978 to 1998 when the two have coincided by coincidence. We can also show that carbon dioxide in the atmosphere always follows an increase in temperature, not the other way around. The idea would be that if CO2 is causing global warming, CO2 would go up and then the temperature would go up, okay? But here's what actually happens, and these are measurements that have been made by a group of researchers in Norway. The blue curve down here is temperature. Temperature's been going up and down, as it does every few years, largely because of ocean changes. And this is the CO2 content of the atmosphere. In every case, temperature goes up and then CO2 follows. If CO2 was causing this temperature to go up, it should precede it, but it doesn't. It follows it in every case and by about the same amount. And this is for short-term changes. The same is true for long-term changes. So the conclusions about CO2 is that the amount in the atmosphere is minuscule. The total change is so small that there is absolutely no way it can cause global warming by itself. It's totally dependent on water vapor, and there's no correlation between global temperatures and CO2. When CO2 goes up, temperature does whatever it wants to do. The comparison of computer model predictions of global warming, when you compare those to actual measurements to see if the models were right, they are totally inaccurate. The models are totally inaccurate. And I'll show you an instance of that in just a minute. The bottom line is CO2 is not capable of causing significant global warming by itself. That's clear from the physics. CO2 is a result of global warming, not the cause of global warming. As you increase the temperature, you increase the CO2 in the atmosphere because there's more that's given up by the oceans.
Dr. Easterbrook, you use the term greenhouse effect.
Oh, I'm sorry. A greenhouse effect is caused by certain gases that will absorb certain frequencies in the electromagnetic spectrum, namely heat. And so the idea would be that as heat is coming from the surface of the Earth upward, being radiated back into space, that certain gases will tend to capture it, if you like, and make the air warmer. And that's why we have such a pleasant climate. It's because we have a lot of water vapor that keeps us nice and warm. Otherwise, we'd be cold because all the heat would radiate out into space. So think of gases that capture heat is the easiest way to think of it.
And I guess I raised the point because the greenhouse effect is not a negative thing.
It's not what?
It's not a negative thing, the greenhouse effect.
The
It's
greenhouse
what allows
effect.
us to live here.
Yeah. the greenhouse effect, the tendency of the greenhouse effect is for various molecules, mostly water vapor, to make the atmosphere warmer by capturing of heat. Okay? How about sea level? Let's take a quick look at sea level. This is one of my favorite pictures. This is New York City with the predicted sea level rise by 2100 by certain people in the UN and other people who shall remain nameless, but who are big advocates of CO2. Actually, I kind of like it. I'm not a big fan of New York, and so it would be kind of fun to see New York as an island. But there are serious ramifications if this were true. Here's Florida, for example, and this is the present coast of Florida. Here's what the coast of Florida would look like if sea level were to rise to the predicted level by the UN agencies. And here's what the old coastline, this is what the coastline looks like now. This is what it would look like if sea level rose somewhere between 5 and 20 feet. The poster child of rising sea level is the Maldive Islands, and you're going to see a big program on TV about how the poor people in the Maldives are going to be drowning and they're going to have to move the entire nation. A world-renowned sea level expert decided to go see for himself what was really there. And what he found was this, that in this picture, for example, this is the 1979 shoreline right here. This is where the sea level was in 1979. Here's where it is now. Here's another place. This is where the sea level was in 1979. Here's where it is now. The irony is that the Maldives are emerging from the oceans, not sinking. They're not being drowned, they're coming up out of the ocean. Here's proof positive. This is documented with the dates of when the shoreline was here, with photographs and measurements, and sea level is actually lower since 1979. It's not sinking. So how much is sea level changing? We've been thawing out from the Little Ice Age, which was about 500 years ago. And temperatures have been rising during that period at a rate of about 0.8 degrees a century, no doubt about it. And as that's happened, sea level has been rising, partly as a result of expansion of the volume of the oceans with the warmer temperatures. And the rate of rise, this is the rate of sea level rise, this is the year. They've been rising at a rate in the early days about 1.5 millimeters a year. That's about the thickness of your fingernail per year. You wouldn't be aware of it. So the total sea level rise in the past century is about 6 inches, not that much. In our lifetimes, it wouldn't rise enough we'd even be aware of it. Here is the official sea level record from the University of Colorado, going back to about 1993, and sea level was been rising at about the same rate, 1 to 3 millimeters a year. It actually went down for a while, from about 206 to 208, and then now it's going up and down a bit, something like that. So no doubt, sea level is going up. The question is, how fast is it going up? Seattle has a really good sea level record, tidal gauge record. This is relative sea level, so we start here in about 1900, and we have records then that go all the way. In this case, they end about 2003 or 2004, and they could be extended. But here's the rate of rise. It's about 7 inches per century. Other areas nearby, Victoria, Vancouver, show the same kind of rise, about 6 or 7 inches a century. But in some places, it's going the other way. For example, Neah Bay, sea level is going down at a rate such that by 2100, it would be lower by 7 inches, not higher. Here's Astoria, 1.7 inches lower at the rate it's going, the present trend. So there are some differences up and down the coastline of the West Coast, which is brought about by local conditions primarily. The global sea level is rising at about 8 inches a century. That's clear. So what about the state of Washington? What about our sea level, potential sea level rise? Here's the curve of sea level from 1993. This is measured up to where we are right now. And if you project that into the future, you get a sea level rise by 2100 of about 7 inches. Not going to be a problem. Here is what the UN agency is predicting. This is their lower estimate. This is their higher estimate. And they're predicting somewhere by 2100, 5 to 20 feet. Look how this curve, the UN curve, varies from reality. Not very realistic, I think. And there's no reason to think that there's going to be any change in this rise. It's been very constant for the past century as we've been warming up. In order to get the sea level rise like this, you'd have to melt the Antarctic ice cap. And we've already seen that's not going to happen. It's not happening now. It hasn't happened in 15 million years, and it isn't going to happen in the future. They're very simple. So sea level has risen only 7 inches as we're thawing out. Rate of sea level is pretty constant, not accelerating. Some places sea level is actually going down. It's going down in Alaska. That is, these areas are emerging. Maldives, Nia Bay, Astoria, they're getting lower, not submerging. The IPCC, this is a UN agency, predicted large sea level rise is unrealistic because global warming has stopped, for one thing, and the Antarctic ice sheet is not melting. The projections are for sea level rise in the Pacific Northwest about 6 inches by the end of the century. How about frequency of severe storms? You see this in the headlines every day. Big storm, must be global warming. And
Dr. Easterbrook, could I ask you a question really quick? I know
Sure.
we're getting behind schedule here, so my apology. But on the slide where you talk about we're going into a global cooling period, what would lead to the sea level rises during a period of cooling if that chart's correct for the last 12 years?
The sea level rise is caused by a number of different things, and one is that as the temperature has gone up over the century, we've gotten actually warmer than the beginning of the century by about 0.8 of a degree. Everybody agrees on that, and that has caused us the volume of the ocean water to expand, and that accounts, people think, for a large percentage of the rise in sea level of like 7 inches in a century, something like that. The other is melting of glaciers. Glaciers certainly did melt from 1915 to 1945, and that added some water. And they also rose from 1978 to 1998. But if you look at the sea level curve, it's constant. It's not going up and down with the glaciers. So it's clear that glacial meltwater is not what's driving this constant rise of sea level. It's probably expansion, thermal expansion is what most people think.
Senator Ranker has a question.
Thank you, Mr. Chair, and thank you for your testimony so far. I have a different question I want to ask, but I want to get to the glacier piece. I was just in Alaska looking at a glacier that I hadn't looked at in 15 years since I was much younger, and it's dramatically smaller than it was. How do you account for that?
But because it was warming from 1978 to 1998, and that's when most of the recession took place, glaciers in Alaska now, in many places, have stopped retreating and are beginning to advance.
So this one in the last 10 years has decreased in size.
It takes a while for a glacier to feel the effect of warming or cooling because there's a lag effect. The ice doesn't respond next year if we have a climate or a weather change this year. The response time of a glacier to a climate change is anywhere from 2 or 3 years to maybe 15 or 20 years. So it takes a while when the glacier is undergoing a climate change for it to put the brakes on and change direction, either going forward or retreating.
Okay, thank you. Thank you, Mr. Chair. So you have mentioned a few times now the IPCC reports. So how do you account for the IPCC report that came out in 2007, which is due to be updated, and over 800 scientists are working on it now, but thousands of scientists worked on this and came to the conclusion that climate change is real and it's human caused. How do you account for all of those folks saying that, and it's obviously very different than what you're presenting to us today?
Could I answer that in just a moment with a slide?
Of course.
I can show you the
Yeah.
I can show you the data, and you will be surprised at the answer, I think. Okay.
Thank you.
So anyway, the point I want to make here is that the frequency of severe storms is not increasing because of global warming. Here are U.S. hurricanes. Actually, you see kind of a downward trend here in recent years. There are fewer hurricanes in the last couple of decades than there were earlier in the century. Here is global hurricane frequency. There's also a slight downward trend. The number of hurricanes is not increasing. Here are strong to violent tornadoes. Again, here's where we are now. We had a bad year in 2011, but not as bad as back in here. And generally, they are down rather. They're higher here than they are here. The number of tornadoes is not increasing as a result of global warming. Precipitation stream flow shows much the same thing. Here is precipitation in the U.S. If you look at the green area, that's increased precipitation, brown is less, and from about 1970-something on, look at the prominence of green over brown. More precipitation in that time, not less. The same thing is true worldwide. And the worldwide precipitation pretty much follows a climatic trend with the warming and cooling trends. So here we have a period when there was more precipitation, here less, here more. It's a cyclic kind of thing. Overall, precipitation and stream flow, I should say, which is this graph right here. This is the average stream flow index from about the last decade, roughly. And there's no significant trend. It's not trending down. Is the only point here. So the conclusions here: a number of U.S. hurricanes has decreased since 1851. The global hurricane frequency has declined since 1978. The number of tornadoes has decreased since 1970. Global precipitation has increased since 1950. Stream flow in the U.S. hasn't changed appreciably in 15 years, and there is no basis for predicting increasing extreme weather because of global warming. A, it's not warming. B, it's not happening. Specific issues, again, reduced snowpacks are a concern for the Cascades. And there have been predictions since 1990 by the IPCC that we will see the end of snow. There were predictions that the next generation won't know what snow is because of global warming. And the East Anglia group of climatologists issued a forecast that the snowfall in England will become a very rare and exciting event. And I think if you talk to many people in England right now, you'd find that it is exciting, but it certainly isn't rare. And here's a headline: snowfalls are now just a thing of the past. And in 2007, the Unit of Concerned Scientists warned that snow would be a problem for ski areas. And there was a big flurry of that this winter. People were predicting that the ski areas are going to have to go into another business because they weren't going to have any snow. The truth is, snowfall is increasing, not declining. Heaviest snowfall, these are headlines, in a century hits Moscow. Anchorage set an all-time record. China is cold, and snow just wreaked havoc with their transportation, worst in 6 decades. Here is the snowpack, snow cover in the U.S. At this date, and as you can see, there's snow clear down to the Gulf almost. Snow is not getting caught. And here is the Northern Hemisphere snow extent. 5 of the 6 snowiest winters for the Northern Hemisphere have occurred since 2002. Here's the Northern Hemisphere snow extent. Snow is not disappearing, it's increasing. We're getting more snow, not less snow. Here's a snowpack in the Cascades. This is the snow water equivalent. In other words, up is more snow, down is less snow. And each of these is a data point for a particular year. If you connect the dots, you get this dark blue curve here. If you do a least squares curve through this to look at the trend, what you'll see is that if we start here about 1995 or so, look at the area that's in this kind of turquoise color versus the area that's in gray. More snow, not less snow in the Cascades. And then since about 2006, we've had generally higher snowfalls in the present, up to about 120 to 150% higher than normal. Snow is not disappearing. There's no problem with water supply by melting snow. In terms of precipitation, here's a map of precipitation of the U.S. Green is an increase in precipitation. green here is up is increase in precipitation, down is decrease. And if you go back to about 1980 or so, it's mostly green, meaning there is not less precipitation, there's more precipitation. So the conclusion is, despite predictions that snow will be a thing of the past, we're getting more of it. It's getting snowier and colder, and we've just looked at snowpacks and temperatures for this winter as well as for the decade. Oops. Here's the acidification thing that you asked about earlier. Acidification, by definition, is the process of becoming acid or being converted into an acid. Ocean acidification means turning the ocean into an acid. That's what acidification means. But the oceans are not acid. They are strongly alkaline. Their pH is about about 8.2. Neutral would be 7. So what's the possibility for changing that? The allegation is that because there's more CO2 in the atmosphere, that's going to put more CO2 in the oceans. And at the same time, they're saying that CO2 is causing it to become warmer. At the present time, we've already looked at these numbers. The amount of CO2 in the atmosphere the change is so small, 8/1000ths of 1% changed in the atmosphere. And the volume of the oceans is about 300 million cubic miles. And we're going to change that from a strongly alkaline solution to an acid with this 8/1000ths of 1% change in CO2. Not possible. There are enough CO2 atoms in the atmosphere to do that. And in fact, just the opposite is happening. As you saw earlier, the effect of global warming is to make the oceans more alkaline, not more acidic, because warming drives CO2 out of the oceans. Even though there's more CO2 in the atmosphere, because the temperature is warmer, the ocean is giving up CO2, not taking it in. It's a CO2 that makes carbonic acid that makes it less alkaline or tending toward more acidic. So with less CO2 in the oceans, it's not as acidic. It's as simple as that. The chemistry 101, does not add up to the claim that the oceans are becoming acid.
I have a quick question for you on that slide also, and Senator Anker does as well, I believe. So you would even say that they aren't even becoming less alkaline? I guess that
we don't really know, because what I can tell you is that this is the equation for the pH of ocean water. And, don't try to understand this, I'll explain it. If you add CO2 to water, you get carbonic acid, and that releases hydrogen, which is what changes the acidity. So that's the basic formula. Seawater can hold more CO2 than cold water than warm water can. So as warming occurs, what's going to happen is it's going to drive the equation in the wrong direction. It's going to drive CO2 out of the oceans, not take more CO2 into it. And the amount of CO2 that's added to the atmosphere in terms of volume is so minute, there aren't enough carbon dioxide atoms to convert 300 million cubic miles of seawater into an acid. It's as simple as that.
One other follow-up, our local shellfish growers have been talking to us quite extensively about the inability to raise some of their shellfish in the Puget Sound waters. And as they measure, I guess they're seeing a move towards becoming less alkaline, a move towards a more acidic. So what if it's not the ocean and CO2 causing, what could be the causes for that they're seeing?
That could well be true, because what we know is that the ocean is not going to become acidic. We know that for sure. It may become slightly less alkaline, but there's no reason for that to occur. Locally, because of the pollution that we're putting into Puget Sound, that may be making Puget Sound more acidic, which has nothing to do with the global seawater. It's a local regional effect by the stuff we put into the Puget Sound. So they may well be correct that the water where the oysters are living might be more acidic. But I can tell you it's not because of global warming or CO2. It's because of some local or regional pollution of the area.
And just really, I guess, acidification, I guess, is kind of a term of art. I'm not sure if it's how it's utilized, but even in that situation, we're not becoming acid, we're becoming less
alkaline.
Less alkaline.
You're never
And
going
so
to get to acid, never.
You're trending this direction, but you're not going to cross over that point to where you're okay.
That's right.
Thank you. I think that helps explain that term to a lot of people also about ocean acidification, what it means in terms of locally here also. Senator Anker.
You actually asked, Mr. Chair, thank you. My former question, you've raised another one, however, which is, so would you say, so let me ask clearly. So the oceans are not becoming more acidic.
I didn't say that. I said that you're not going to make the oceans acid, and the total range of variability of pH in the ocean varies from about 8.2 to 7.9 in a transect area of the ocean, which is greater than most of the changes in any given site.
At any scale, are the oceans becoming more acidic?
No.
Okay, and then...
Because acidic means it's an acid. To make it more acidic means it making more acid than it was, which by definition is a non sequitur.
Okay, okay. And then my second question that came out of the chair's question then is, so locally where we are seeing ocean acidification, whether that's the right term or not, according to your information, I'm not sure, but...
Less alkaline would make me happier.
Less alkaline, okay, so less alkaline. So we're not just seeing that in Washington State. I'm working with colleagues in Maine, Maryland, California, Oregon, Alaska particularly. Alaska, who has significantly less population than us, and most of the watersheds are not running out of agricultural lands or other areas or pollutants. They're running out of relatively pristine areas. So is the impact there also from some sort of pollution?
I think it probably not would be my guess. I don't know that because I don't know the numbers you're looking at. I'd have to look at the numbers to tell you if there's a difference between some regional effect like pollution in Puget Sound or whether there is a water temperature. The principal governing factor is water temperature. And in places where you have upwelling, where there is cold water coming up to the surface. Cold water can hold more CO2 than warm water, and so that might actually be causing it to become a bit less alkaline than before, and in that case, it's a regional thing, not pollution.
Thank you.
Okay. So we've talked about this. Oceans are alkaline, not acidic. The governing factor here is the temperature of the ocean water. Let me answer your question now about all these people who are the so-called consensus. You will see, I see every day, quoted, 97% of all scientists believe that man-made CO2 causes global warming. That's a fraudulent statement. And the statement that there is a dominant consensus among scientists that CO2 is causing global warming is not based on any known fact. And let me tell you where this number comes from, and let me tell you where that off-quoted statement comes from. There was a graduate student who, this was in Indiana or Illinois, sent out 10,257 questionnaires to climate scientists. He got 3,146 back responses. Of those, he selected either 77 or 79, I'm not quite sure the numbers, correct, it doesn't matter, that he handpicked out of these 3,000 responses. And he asked those people, do you think CO2 is causing climate change? And funny thing, all but 2 said yes, because they were hand-selected. And so the real number is that there were 77 or 75 scientists out of 3,100, not out of 77 or 79. So if you divide this number over that number, you get 2%. So the consensus that you're hearing is 2%, not 98%. If you were to then look at, well, what is the consensus? Whoops, let's go back to this. I have some information that you would find interesting. It's called the Petition Project. And this was a petition And let me read what the statement says. It says, there is no convincing scientific evidence that human release of carbon dioxide, methane, or other greenhouse gases is causing or will in the foreseeable future cause catastrophic heating of the Earth's atmosphere and disruption of the Earth's climate. How many scientists who have degrees in one of the sciences signed that? And the answer is 31,487. As opposed to the 77 in this survey that's so oft quoted. So I would say the consensus is that scientists do not believe that CO2 is causing global warming, not the other way around. So if you compare what you're seeing on the screen with what I've just read you, of these 31,000 scientists who signed this statement, all have degrees in one of the sciences, and 9,029 have PhDs in those. And the expertise of these is atmospheric, environmental, earth sciences, computer and mathematical sciences, physics and aerospace sciences, chemistry, biology, agriculture. These are real scientists, and there are 31,000 of them. In order for the statement to be true that either the consensus is that CO2 is causing it, you would need to have 32,000 people signed, and there are about 4,000 people who were involved in the IPCC project, and by admission of the chairman of the IPCC for the UN, 80% of those are non-scientists. If you look at the 27 people who wrote the executive summary for the 2007 report, which is so often quoted, guess how many have experience in meteorology? None. So there's the answer to your question.
Senator Billick has a question.
Thank you, Mr. Chair. So my understanding of the consensus was not based on a survey. It was based on a review of the scientific papers, the peer-reviewed scientific papers. It showed that the overwhelming majority of scientific papers, peer-reviewed, showed either that had a consensus about climate change being human-caused, and a few that came to no conclusion, but very few that came to the opposite conclusion. So I guess I'm just having a little trouble that you're saying that that number is based on just that one methodology, when I think there are other methodologies to arrive at what the scientific consensus is.
Your statement could be true, but let me tell you why it could be true. And that is that the editorial boards of virtually every scientific journal, probably in the world, but certainly in the United States, the Geological Society of America, the American Geophysical Union, Science, Nature, all of these places, will not even read a paper that has anything negative to say about CO2. So it's not surprising that there are no papers published that are critical of CO2 as a cause, because their editorial boards will not permit it. And that is a fact, and there are some numbers that go with that. I don't happen to have them handy, but it's clear that the peer review process, the editorial process, has been taken over by what I call CO2 dogmatists who will not permit publication of anything that's in any way critical of CO2, and that's a fact. So your statement could be true. There might be more peer-reviewed papers being published right now because they won't publish anything else. Okay, let's finish this up quickly. So how do we go about predicting climate then? How are we going to figure out what the state of Washington needs to do in the future? There are two ways to do it. One is the UN way, the IPCC way, which is with computer models. And computer models, like any other computer thing, is garbage in, garbage out. Whatever you program the computer will be, it's what comes out the other end. They do not consider real life changes in the atmosphere, in the oceans. They do not consider real physical data. It's all theoretical. The other way is to use real physical evidence to establish cyclical patterns. This is on-the-ground research, the kind of information I've been showing you. So let's compare the two. Which one gives us the best answer? Which one should we rely on to go about predicting what's going to happen in the state of Washington? This black curve here is a curve that I took as is from the official IPCC website in the year 2000. This is what their projection was in the year 2000. It actually continues on down here a ways, but I don't have it on this curve. And they were predicting that the temperature between 2000 and 2010 was going to be increased by 1 full degree, a 1 degree warming. which is greater than the warming for the entire century. That's what they were predicting in a decade. Here is the actual record, which is the satellite record that we've already seen, and look at the gap between the two. The models failed miserably. They weren't even close. Therefore, what trust can you put in models if they cannot even predict 10 years down the line within 1 degree? They're useless. So what we can do then is look at real physical evidence to predict where we're heading. What kind of evidence can we use? We can use the natural, observable evidence, which looks something like this. The Pacific Ocean has 2 modes, a warm mode and a cold mode. This is what the temperature looked like between 1945 and 1977 in the Eastern Pacific. North America, we're about right here. Blue is cold, orange and red are warm. The whole coast of the U.S., clear up in the Gulf of Alaska, at this time was cool, and we had global cooling down here. This is blue down here is cool, red is warm. In 1977, in 1 year, there was a flip, and the Pacific Ocean changed from, in this case, cold to warm. The red is warm, and look what happened. We had global warming. Surprise, surprise. The message here is that the temperature in the Eastern Pacific governs the climate of North America. It's that simple. And so what we see is a regular pattern of a warming ocean water, cooling ocean water, warming ocean water, which is exactly mimicked in the global climate temperature. Exactly. And in this case, it's like a toggle switch on-off. This change from cool to warm mode occurred in 1 year off the coast of North America, and the climate changed that quickly. CO2 doesn't change that quickly. This is not a climate change that could have been brought about by CO2. And here's verification of that. This is what the temperature looked like off the coast of North America in 1977. And also in 1998 is very similar. In 1999, look what happened. All this nice warm water off the coast here, the red and the yellow, has now changed to cold with blue colors here. In 1999, which is 1 year after the second highest temperature of the century, behind 1936, I went out on a limb and I predicted that because of the change in the pattern of the ocean water temperatures that we're in for about 30 years of global cooling. And people thought I was crazy. After the hottest year in a long time, how could I predict we're headed for global cooling? Truth is, it happened. I was right. The last 15 years have been cooler. We've had 15 years of global cooling, as I predicted in 1990, based on the geologic record of the history of changes in the ocean water temperatures off the Pacific. Here's where we are today. Look at this. Still cold. It has been cold now for 15 years, the ocean water, and guess what? We've had 15 years with no global warming and global cooling, and that's why. So all we have to do is to read the past history of these ups and downs, and this is what you get. Here is the ocean water temperature. When it was warm off the coast of North America, we had global warming. When it was cool, we had global cooling. And this is a period of about 25 to 30 years generally. 77 to 98, ocean water warm, global warming. And then in 1999, we shifted to cool, and we got cooling out to here. So it doesn't take much of an extension to say, okay, this is going to be a repeat of this, and we're in for about 25, 30 years of global cooling.
Senator Anker has a question.
Thank you, Mr. Chair. Okay, in your previous slide, I have 2 pieces to this. Your previous slide it had 97 up there. If I remember correctly, 96, 97 was one of the more powerful El Nino, La Nina events that we've seen in decades.
1998 was 1998.
98? Okay,
yes,
so
that's
97,
right.
so that's it coming in then. So how does that get taken into account in your information? And then I've got to come back to the question I asked earlier, because all the data that I've read and I have before me shows that particularly in the last 12 years, we've seen an increasing temperature. We've seen more records broken Is that again because...
I just showed you evidence to the contrary of that.
I know, but I'm telling you that I have peer-reviewed data in front of me that suggests otherwise. Is that because that peer-reviewed data has been manipulated?
That would be my guess, yes. But I don't know what data you're talking about. If you'd like to send it, I'd be happy to respond.
Science Foundation, the IPCC, the UN, the
The answer to the question is yes.
Universities like University of Washington, Western Washington University, and others.
Well, let's. I'd like to finish up the presentation,
Sure.
and we can go into that stuff in a second. And I have one question also on the ocean upwelling issue here with regards to the temperature. Because getting back again to our shellfish issue, which is an important one to myself and Senator Ranker and some other folks here in the shellfish growing regions. But when we have the ocean upwelling that could lead to the global cooling aspects that you spoke about, and whether or not we agree or we take a look at it, that we can look, would that be due to the cooler water and the upwelling hitting the coast and coming into Hood Canal, which could result in a lessening of the alkaline in those waters? I mean, that's an interesting one to take a look at going forward.
That's certainly possible. The solubility of CO2 in seawater, which is what governs the generation of carbonic acid, which is what makes the seawater pH go up or down, is a function of temperature. And so the colder the water, the more CO2 that can be held by the seawater, therefore the less alkaline it is. And if you warm it up, then the sea will give off CO2 in the atmosphere, and it's actually the ocean that's controlling the composition of the atmosphere, not the other way around. So the answer to your question is that could explain some regional differences, because we know that there is upwelling that happens about every 2 years off the coast of South America to the equator, and there certainly are upwellings elsewhere. So that could be responsible for a change in the pH of the seawater. Yes, is the answer.
How are we doing on time here? How many more slides do we have?
I'm done.
You're done?
Any more questions? I'm done.
Oh, I didn't know we were finished there. Any more questions from the committee? Senator Billig.
Thank you, Mr. Chair. So I want to go back early in the presentation. You talk about real evidence, and it seems there's one of the issues is the data. And I think if you said that NASA is manipulating the temperature data, their temperature data. It's hard for me to believe that, and I was just wondering what would be the motivation that they would have to manipulate temperature data? Why do you think that?
I have no idea. I have no idea what people are thinking. What I can tell you with absolute certainty is that I have seen the original data that was collected at many places, and then I have seen that same data graphed by NASA, by NOAA, and by the CDDC, which is an arm of NASA, in 1980, and it was different. And I saw it again in, 1990, 2000, and it was different yet. And I saw it again in 2000 and something or other, and it was different yet, and each case higher. So I'll let you draw your own conclusions for that. I have no idea about motivation or anything else. I'm not a mind reader. All I can tell you is what I observe, and that is well documented.
Senator Ranker.
Thank you. Along the same lines, and thank you, Senator Billig, for following up on that line of questioning. I think it's really important. You've mentioned a couple times in your presentation that none of this is being reported on because the media won't cover it. Could you enlighten us a little bit more on what's happening there?
If you look at any major network TV program, how many headlines have you seen that say we have unprecedented global warming, and how many headlines have you seen that, gee folks, the climate's cooling, gee, it's the coldest winter in 100 years in Europe, gee folks, it's cooler? And the answer for my own personal experience is none. I can tell you personally that a few years ago, the New York Times did a feature presentation on some of my material, and I was called by every major national TV network, ABC, NBC, CBS, Lara, the whole bunch. And then one by one.
Fox is behind you. You better say Fox.
Fox, CNN, everybody, yeah. And so guess what? NBC called back and said, oh, we decided not to do that. CBS called back and said, oh, we're not going to do that. MSNBC did do an interview, CNN did, and Fox did. There were three, and CBS later did. But ABC, NBC, all of those withdrew their interest in interviewing. So from a personal experience, I have experienced that news blackout, and all you would have to do to recount the headlines of, gee folks, we have accelerating global warming, we're all going to die, and how often do you see reports of it's the coldest winter in 100 years? You don't see that at all. You just count them, and it's a no-brainer.
Dr. Easterbrook, I had a question on one of your early slides. If we could go back, I think it was slide number 3 or 4, if we could get in there. And
let's go to...
one was CO2 graphed with the temperatures, and it showed the curve if you were to extend it with the CO2 from the 40s going onwards.
Okay, I'm going to go back.
Do end show, and then you can go to slide sorter.
Stop me when I get there.
Okay. If you go all the way down to end show, you can pull up slide sorter if this is a PowerPoint. Yeah, there
Here we
you
go.
on the left.
Okay.
So go up to the top, go up to the top. We back up, back up, back up, all the way to the top.
Okay, we're at the top.
All right, now come down to that, keep right there, that slide, second one from the top on your list right there.
This one?
Yeah.
That one.
So I don't understand about this one. If we're showing temperatures, this I think gets back to Senator Ranker's question a little bit about coldest time versus coolest, you know, in terms of the last 12 years. Mm-hmm. When I look at the chart, though, what I see the temperatures listed for the coming into it ends in 2000. That would be the difference. It ends in 2000 going backwards, being warmer than it was in the 30s. So maybe I'm not reading the chart correctly.
No, you're reading a chart correctly. This is data. If you look at the source of the data here, HADCRUT is the climate data that comes from East Anglia in England, which was the site of the ClimateGate scandal, incidentally, which is another issue altogether. And so their data tends to be roughly the same as the NASA manipulated data. And
I didn't ask that question
very
very well. Yeah. Could you go to the slide right above it? Maybe that's the one I was thinking about.
This one.
Yeah, and that. Oh, so I see now in that one you see the spikes back in the 30s, but even there is the same. I don't understand this data because that still looks to me like it's cooler in the 30s on that data than today.
Okay, well, what I can tell you is that if you look at the source of the data, this is HADCRUT data, which is the East Anglia data, which is the same as the NOAA and the NASA data, and they have suppressed this. I can show you the before and after the suppression. And essentially what they do is they make what they call an adjustment. And you can imagine a glass of pure water and a glass of sludge. And what they do is to say, well, we've got these weather stations that give us pure water, but we've got these other ones that are sludge because the stations give really inconsistent data. So what we're going to do is we're going to mix the two together. We're going to homogenize them. They call this homogenization of data. And then what you end up with is something that's, guess what? It's no longer pure. And so what they do then is they make the correction based on this mixture rather than just using the pure data. I'm looking at the pure data. They're looking at the sludge affected data.
Gotcha.
Okay?
Do you have any other questions? Seeing none, I'd just like to thank you for the chance to come in today and testify in front of the committee, Dr. Easterbrook. I thought it was a very interesting presentation. And I think that obviously there are disagreements in Olympia and in the scientific world with regards to the material you presented today. But I think as legislators and members of the Senate Energy, Environment, and Telecommunications Committee, it's important that we take a look at all the data that's available to us to be able to make informed decisions as we go forward, because we have some major decisions that we're making here in the coming years with regards to long-term energy structure issues in Washington State and how we handle a lot of different decisions coming before us. So I think it's important that we take a good hard look at all of the data that we can and continue moving forward in our role as legislators to try to make informed decisions. So I think that your being here today was a good one for us to be able to take a look at the data that you present to us. And I really appreciate you taking the time out of your schedule to be here with us today.
Well, thank you for inviting me, and I would urge you to don't believe what I say. Look at the data, and you can arrive at your own conclusions because data speaks way louder than opinions.
We should go back to slide number 1 for your presentation,
yes,
I guess.
Yes.
You know, all
others trust all data. Data.
If we have comments that need to be made, we can take them. Otherwise, we do have bills we have to get through also. Senator Honeyford.
Yes, I just wanted to ask staff if they could make color presentation of these slides available to us. Thank you.
Great. Senator Ranker.
Thank you. Just a closing request, and I thank you for taking time out of your schedule for being here today. I would like you to provide the committee copies of any of your models or modeling that are peer-reviewed and where those were published, just so we can get a copy of that as well. I'd really appreciate it.
Yes, I can tell you that everything I showed you today has been peer-reviewed, everything.
Okay.
And I can give you references if you'd like.
Okay, excellent. Thank you.
Great. Thanks again for being here. And that concludes the presentation. We will now go into some back into committee hearings on topics that might not be as interesting as this.